single proportion test. Now we are going to see type 2 problem based on sample size, which is known, population size capital N also known, small n and capital N. First type, sample size is known and population size unknown, right? We'll see the test procedure, right? So notation, capital P population proportion, as usual everything, right? P, small p is sample proportion, small n sample size, capital N population size. Next test procedure, step 1 to find the value of Z, calculated value. So we are going to use the test statistics. Z is equal to P minus capital P by root of capital N minus N by capital N minus 1 into PQ by N, right? Here Q is equal to 1 minus P, right? Small q and capital Q both are. Step 2, defining hypothesis. So hypothesis for first two-tailed, then two-tailed values 10 at 90%, 95%, 99% confidence interval, or 10% level of significance, 5% level of significance, 1% level of significance. They have given value. So first row, two-tail test, second right-tail test, right? Third one, left tail test. Step 3, we are going to see the conclusion as usual. For 2 and right tail test, Z calculated value is less than tabulated value, is not accepted, otherwise it is rejected, right? And the left tail test, so because we are taking the negative value, so calculated value less than tabulated value, it's not rejected if you are taking the minus values, right? Otherwise same one as per previous, right? Next confidence interval formula, x bar plus or minus z alpha root of n minus n by n minus 1 into pq by n. Standard error which is equal to root of capital N minus small n by capital N minus 1 into pq by small n. First problem. In a population of 1000, a sample of 100 people in a place, 54 are like tea and the rest are coffee drinkers. Can we assume that both tea and coffee are equally popular in the state at 5% level of significance, right? In an area there are 1000 people, so they have taken a sample of 100 people, right? So they have given capital N population size, that is equal to 1000, sample size that is equal to small n is equal to 100. 54 are like tea, x be the number of tea drinkers, right? So out of 100 you are having 54, so proportion, sample proportion P is equal to x by n, that is equal to 54 by 100, that is equal to 0.54, and Q is equal to 1 minus P, that is equal to 1 minus 0.54, that is equal to 0.46, right? So defining hypothesis, null hypothesis H naught, so there is no significant difference, that is both tea and coffee are familiar, popular in the state. Alternate hypothesis is opposite to that, there is a significant difference. Since coffee and tea drinkers are equal, so each having equal proportion 0.5, so that is why we are taking population proportion P, capital P is equal to 0.5, right? So alternate hypothesis, P not equal to 0.5, both are equal, right? Both are popular in means, so half of them drinking tea and half of them drinking coffee, that is the population, right? So that is why we are taking population proportion 50% of the population, right? Alternate hypothesis, P not equal to 0.5, two-tail test we are using. Q is equal to 1 minus P, that is equal to 0.5. Now test statistics, Z is equal to P minus capital B by root of capital N minus N by capital N minus 1 into PQ by small n. Substituting these values, 0.54 minus 0.5 root of 1000 minus 100 by 1000 minus 1 into 0.5 into 0.5 by 100, that is equal to 0.8434. Calculated value of Z is equal to 0.8434. Tabulated value at 5% level, two-tailed 1.96. So next conclusion, calculated value of Z is less than tabulated value, therefore H0 is accepted. Therefore equally popular in the tea and coffee are equally popular in that particular state. Thanks.